Okay, so in this video, we're going to do 3 different problems here, and the idea is we're going to take our logarithms and we're going to simplify. And what that means is if you read the problem, we're going to write it as a sum or a difference of logarithms. So we have to apply those log properties. So the log property that we're going to use here is I see the division symbol, so I know that a log of any base where there's numbers being divided is the same as the log of the numerator minus the log of the denominator. So I'm going to go ahead and apply that to this problem. So that means log base 3 of 3x minus log base 3 of 9. Now, what I need to do is I need to take this a step further, okay? Because this 3x is multiplication. I can split this. So we have that other property where if we have log of 2 terms being multiplied, I can do log of 1 term plus log of the other term. So I'm going to split this. Log base 3 of 3 plus log base 3 of x minus log base 3 of 9. Now, as we go through this problem, we need to look at this step. We've separated all the logarithms. We need to try and simplify now. Well, log base 3 of 3. I'm going to create a little side work here. What does log base 3 of 3 equal? I don't know. Well, let me rewrite it in exponential form. 3 to the x is equal to 3. Well, that power is 1. Well, that just equals 1. So that's going to reduce to 1. And I know that it's going to reduce to 1. The trick is, I'll write this over here on the left-hand side in blue, is that log base 3 of 3 to the first power. Because these guys are all the same, I'm left with just the exponent. Okay? Plus, change colors here, plus log base 3 of x. I can't do anything with that because of the variable. Minus, well, 9 is the same as 3 squared. So working with that trick that we just talked about, that's going to reduce to 2. So log base 3 of x minus 2. And so when I combine my like terms, I get a negative 1 plus log base 3 of x. So we need to simplify if possible, which is that last step. Once I separated everything, I simplified. We're going to write it as a single logarithm, and then if we can simplify, we're going to simplify. We're just going to follow order of operations and work left to right. Okay? So I'm going to put these guys together first. They have the same base, so I can combine them, and the combination is using multiplication. So 2 and 10 is 20 minus log base 4 of 5. So then because of this, I know I can write it as a single log and divide terms. Now at this point, I can look at 20 divided by 5 and see if that reduces. And it does. That's log base 4 of 4. Well, with our little trick, it's 4 to the first power. This guy cancels out, and this guy is the same as 1. Video. We're going to write each expression as a single logarithm, then simplify if we can. So with this one, one thing I want to tell you is that we have this power property where I can take any power and either write it as the power of the term here or drop it down so it's in front. If we're going to combine as a single logarithm, the first step I have to do is I have to use that power property and write these coefficients back up as exponents. And that's going to be my first step. Okay? And now we have same bases. So we're dealing with addition, so I know I'm going to multiply my term, so I write it as a single log, and I have y to the 7th, x to the 5th. And I can't simplify any further, or the simplification is just moving those 7s, but they're variables, nothing can reduce. So those are 3 examples on how we can simplify either a single logarithm or writing it as a sum or a difference. So expanding or condensing logarithms.